Now it's time to finish up Lesson 11, our discussion of planet Earth and its interior. Now we're going to focus on heat. As it says here, Earth's interior is hot, and we know that's true. We have several expressions of this. One, pictured to the left, volcanic eruptions. As lava comes out, along with those toxic gases, it's very hot. Temperatures approaching 2,000 degrees Fahrenheit. So that's coming from Earth's interior. That tells us Earth's interior is quite hot. On the right-hand side, a natural hot spring. This is near the Sierra Nevada mountains of California. That water comes out at a temperature usually between 90 degrees Fahrenheit and perhaps 110 degrees Fahrenheit. So that's also an expression of Earth's interior heat. So you're dying to know, what are the sources of heat? Well, we have some ancient sources that probably are no longer releasing heat energy. One was from that process of accretion that formed Earth some 4.6 billion years ago, and actually further into the past than that. Impact of Earth with a Mars-sized object also generated a lot of heat, enough to make Earth molten throughout. Those ancient sources of heat, according to geophysicists, have long dissipated, so probably no more heat from those. That takes us to point C here. Another source of heat from radioactive decay of unstable elements in Earth's interior, things like uranium, for example. We think this is still occurring. Probably trapped deep within the core, lots of these decaying elements, and as they decay, they release heat energy. So geologists are pretty certain this is the source of Earth's interior heat. So as that heat is released from the core, it's going to move toward Earth's exterior. That's what heat does, goes from where it's hot and travels to where it's cold. Just think about it for a second. If you go outside on a cold winter day, and if you're underdressed, you'll start to get cold. That's because you're losing your heat to the outside atmosphere. Same thing happens from Earth's interior. In solids, heat transfers by the process called conduction. Says illustrated, the handle is conducting heat, atom by atom, traveling from where it's hot to where it's relatively cool, and eventually your hand would feel that heat. So that's how conduction works. Another method of transferring heat energy within Earth's interior, it's by a process called convection. It's more complex than conduction. So going back to our illustration, that pan of water being held over a campfire, the water is starting to heat up. At the bottom of the pan, in contact with the heat, that's where the water gets hot the quickest. As you heat it up, you reduce the density of the water, it rises upward, displaces the cooler water at the top, and that sinks down to the sides, as is clearly illustrated. That generates movement of the material. So convection, fundamentally different from conduction. Here we're moving material. With conduction, nothing moves, just the heat transferring through. So at this stage, we're ready to go back to the diagram. We've just about completed it all, but I'd like to finish this off and label where different types of heat transfer are occurring as you go from the inner core and up through the lithosphere. So let's shift gears to that.